A composite material is a material made from combining two or more non-homogeneous substances, that is, matrix substance and strengthening substance. The matrix substance surrounds and binds the strengthening substance together. For example, wood. Wood is a composite material. This is because wood consists of lignin, which is a matrix substance, and cellulose fibers, which is a strengthening substance. Both components of a composite materials have different physical and chemical properties. When combined, the composite material formed has better properties than the original components.
Composite materials and their uses, widely used in the development and advancement of technology nowadays. For example, reinforced concrete. Concrete yang dibekukuhkan is produced when steel bars or wire mesh as the surrounding substance is immersed in concrete as the matrix substance. So, reinforced concrete is widely used in the bridge construction, dams, and building. Another example, fiberglass. When plastic is strengthened with glass fiber, plastic is matrix substance and glass fiber as the strengthening substance. And this composite material is used to make helmets, car bumpers, and printed circuit boards. Another example is optical fiber consists of 3 layers. The innermost layer is a core that is made up of silica glass fibers as the strengthening substance, and the core is encased in a second layer or cladding that is made up of glass or plastic as the matrix substance. Outermost layer is made up of plastic acts as the protective jacket as the matrix substance. So optical fiber are used to transmit information and data in the form of light. Light moves through the optical fiber in the core section. Core and cladding have different refractive indexes, so this composite material has replaced copper wires in video cameras and connects computer in local area network (LAN). Photochromic glass is formed when glass as matrix substance is combined with silver chloride (AgCl) and copper 1 chloride (CuCl) as strengthening substance. When exposed to light, photochromic glass darkens. This is due to formation of silver atoms Ag that prevents the passage of light. In dim light, copper 1 chloride CuCl in photochromic glass catalyzes the reverse process so that glass becomes transparent again. Photochromic glass protects the user from UV rays and is suitable for use in car windows, building windows, and also camera lenses. Superconductors such as lithium barium composite YbCO has superconductivity properties other than alloys. This superconductor is used to make electromagnets that are superconductor magnets or supermagnets. Superconductor magnets are light and have strong magnetic force. Superconductor magnets are used in particle accelerators and involved in nuclear magnetic resonance (NMR) machines and magnetic resonance imaging (MRI) machines.
So now we go to the last part of this subtopic, which is comparison and difference in properties of composite materials and their original components. Composite materials have different properties compared to their original components. Firstly, we have concrete. Concrete can withstand high compression forces but will break if subjected to high stretching forces. Combination of concrete and steel bars or wire mesh can increase the ability of the concrete to withstand compression forces. So, concrete has the properties like high compression strength, low stretching strength, and resistant to corrosion, while steel bars or wire mesh has the properties like high stretching strength and corrodes easily. So when concrete and steel bars or wire mesh combine, they will form reinforced concrete, which has the properties such as high compression strength, high stretching strength, and resistant to corrosion. Next, we have plastic matrix. Plastic matrix consists of plastic that is weak, soft, and easily burned. The properties of plastic are reinforced by adding glass fibers. Plastic has the properties like low stretching strength, low heat and electrical conductivity, resistant to corrosion and durable, while glass fiber has the properties like high stretching strength and low heat and electrical conductivity. So when plastic and glass fiber combine, they will form fiberglass that has the properties like high stretching strength, heat and electrical insulator, resistant to corrosion and durable. Other than that, optical fiber has high compression strength although the original component that is glass fiber is brittle. So plastic has the properties like high compression strength and flexible, while glass fiber has the properties like low compression strength and hard. So when plastic and glass fiber combine, they will form optical fiber which has the properties like high compression strength and flexible.
Okay, for the photochromic glass, it was combined with glass and silver chloride. The glass properties is transparent, does not absorb UV rays, and not sensitive to light. For the silver chloride, the properties is transparent to visible light, absorb UV rays, and sensitive to light intensity. The properties for the photochromic glass is transparent, absorb UV rays, and the absorption of UV rays depends on the light intensity. So that is the comparison in properties of photochromic glass with its original components. Glass is transparent and does not absorb UV rays. Silver halide salt crystals such as silver chloride is transparent to visible light and absorb UV rays at the same time. Then we are going to the superconductor. The original components for superconductors is yttrium tricarbonate, copper 2 carbonate, barium carbonate, and oxygen. So for the original components property is high electrical resistance at room temperature. So the superconductor properties is no electrical resistance at very low temperature. Superconductors can conduct electrical current without any resistance at very low temperature, whereas its original components cannot.